Okay, everybody. Here we are. We're going to be talking about another topic here under the umbrella of algebra. Today, we're going to be talking about solving quadratic equations using a specific method, what we call completing the square. This first video that I'm putting together on this is just some basics that are out there. I will have also an additional video where we will talk about more complex quadratic equations that need to be solved. So let's go ahead and just begin jumping right into here. So what I want to talk about, we're going to talk about this first example here that I have, the quantity x squared plus 6x plus 5. This is a quadratic trinomial. When we complete the square, what we want to do is we need to be able to create what we call a perfect square. And so what we're going to do is we're going to work with these first two terms. So I'm going to begin by putting parentheses around the first two terms, both the quadratic term and the linear term. I really don't care about what is here or if this constant is even here. I can even have something that doesn't have that constant there, and this will not change. The first thing that I'm going to do is I'm going to give myself some room inside here. So I'm going to basically recopy the x squared plus 6x. I'm going to leave some room on both the inside of the parentheses and the outside of the parentheses. I'm going to copy this plus 5 here, and it's all going to equal 0. I do this because I know what I'm going to end up coming back and doing here in just a moment. Now this is where the magic of completing the square happens. In class, we're going to discuss why this works and how it's connected to this graphically. But right now, I just want to show you how this works. We're going to go ahead and take this middle number 6. I'm going to copy this off to the side 6. And every single time, I'm going to do the same thing. I take that middle term, 6, and I divide it by 2, and then I square it. In order of operations, I'm going to do my inside my parentheses first. 6 divided by 2 is 3. 3 squared gives me 9. That is my magic box. I'm going to go ahead and put a box around that because that is the number that I'm going to be placing here and here. So I'm going to begin by adding the 9 on the inside. But you can't just add 9 to an equation and keep it equal. So for this to stay equal, what I must do is I must subtract 9 as well. So I'm adding on the inside and subtracting on the outside. My net result is basically I didn't add anything to the equation. Now, if you came back and you looked at this and you wanted to factor this, I'm assuming that you've been taught factoring already in my algebra class we have before we do completing the square. I would go about factoring this. And if I were to factor this, my x squared term would break up as x and x. I would need two numbers that multiply to equal 9 that add up to 6. That is going to be 3. It's going to be a 3 and a 3, and this is a plus and a plus. If you checked this out, x times x gives me x squared. X times 3 gives me 3x. 3 times x gives me another 3x. That gives me a total of 6x. And 3 times 3 gives me 9. Thus, it working here. On the outside, I just have two constants that I need to put together. Negative 9 plus 5 gets me a negative 4. I'm going to go ahead and set that equal to 0. Now, instead of this, writing this in factored form, I could actually write this as a square, thus the name of this method that we're going to do. I'm going to go ahead and write x plus 3 quantity squared. I'm going to go ahead and copy that negative 4 down, and that's still all equal to 0. At this point in time, you have actually completed the square. The whole idea of completing the square is to be able to write a perfect trinomial in its factored form written as a square. And at this point in time, you actually have completed the square. From here out, I'm going to finish this by using square roots. And that's how I'm going to go ahead and solve this. So I'm going to solve this by isolating the square term. So I'm going to go ahead and add 4 to both sides of the equation. Here's my line here. I'm going to have x plus 3 quantity squared is all equal to a positive 4. And now I'm going to take the square root of this to get rid of the square term, the square root of this. Here, when I take the square root of the x squared term, I'm going to end up with x plus 3. The square root and the square cancel each other out. And I have to remember something here, is when I take the square root of a square, I must end up with a plus or minus. And so this is very, very important that you write plus or minus 2 at this point in time, not later on. Right now, the moment that you take that square root, you're going to put the plus or minus on there. The last thing that I'm going to do in regards to solving this is subtract 3 on both sides. Here we are here, and I'm end up with x is equal to, I'm going to put this in front, negative 3 plus or minus 2. Now you'll notice that these two terms can actually be put together here. I have a negative 3 and I have the number 2, and thus I can actually write this as two individual integer values. So I'm going to start by doing the addition first, negative 3 plus 2, which gives me a negative 1, and then my second answer is going to be negative 3 minus 2, which gives me a negative 5. I'm going to go ahead and box both those answers. Wow, you're talking about a lot of work on one problem. The beauty about completing the square is that it always works. Let's go ahead and move over here. I'm going to do my second example now. I'm going to do this one a bit faster. And so let's go ahead and walk right through this again. So remembering that I don't care about any of the other terms except the first two terms when I go about completing the square. I put parentheses around those first two terms. I'm going to go ahead and rewrite this with just the x squared minus 8x. I'm going to leave myself some room on both the inside and the outside. I'm going to copy the negative 20 over here a little bit off to the side, and thus I can move forward. Now, once again, I'm going to go ahead and do my magic here, and this is really the magic of completing the square. I'm going to take the negative 8, I'm going to bring it off to the side here. I'm going to do the same thing that I did last time. I'm going to divide it by 2, and I'm going to square it. Negative 8 divided by 2 is negative 4. Negative 4 squared gives me a positive 16. I'm going to go ahead and put that in the box. That's my completing the square box. I always box that thing. I'm going to go ahead and add this on the inside, and to keep this balanced, I'm going to subtract 16 on the outside. Now when I look at this here, I can actually go back and factor this. If I wanted to factor this quadratic here, I'm going to go ahead and factor this, breaking up my x squared term as x and x. I need two numbers that multiply to 16 that add to 8, and that's going to be a 4. I notice that this middle term is negative, therefore both of these terms are going to need to be negative. I can put together these two constants on the outside, negative 16 minus 20, and that gives me a negative 36. I'm going to go ahead and continue on by placing these and rewriting them as a perfect square. X minus 4 quantity squared minus 36 is all equal to 0. Now, once again, I have officially completed the square from here on out. I'm just solving this quadratic by using square roots. And so I'm going to add 36 now to both sides of this equation to be able to solve for that. I'm going to go ahead and copy this down. X minus 4 quantity squared is equal to 36. I'm going to take the square root of the left, and I'm going to take the square root of the right, and I'm going to have x minus 4 equals, once again, as soon as I take the square root of a square, I must have plus or minus. So there's my plus or minus symbol. The square root of 36 is 6. Lastly, I'm going to move over this 4 here. I'm going to add 4 to both sides, and I'm going to end up with x is equal to 4 plus or minus 6. Here, once again, you'll notice that I have two integers that actually can go together. That always isn't the case, but on these basic ones that we're doing, they're going to be all clean. I'm going to do 4 plus 6. That's going to give me a 10. And then 4 minus 6, which is going to give me a negative 2. I'm going to go ahead and box both of those answers. All right, so we started off with two examples here. I'm going to go ahead and slide this paper up here so that you get it in your field of view a little bit better here. Now would be a good time for you to pause the video so that you can go ahead and try both of these examples that I have here down on the bottom here. So go ahead and try this example here by yourself and try this example here by yourself. I will come back in a moment. Okay, I'm assuming that you had paused the video, you had tried both of these examples, and I'm going to come back and I'm going to do these quite quickly. So I'm not going to explain, I'm just going to do them quickly so that you can confirm your work here. Okay, hopefully you have paused the video, gone through, and you've watched me do these quite quickly. I want to make sure that you check your answers, make sure that you're good on each one of these before we go ahead and move forward. All right, so I'm going to go ahead and flip my paper over. This is a good time for you to flip your paper over. This is the second part of this worksheet here, and we're going to go ahead and talk about this here. So this is the back now. We want to talk about some variations that you can see. So I've got some variations that are a bit different than what we've seen in the front. You'll notice with this first example here, I notice that the equation is not equal to 0. And I'm going to tell you that that's okay. We can just leave it that way. There's no reason to do anything to this, because when I complete the square, I only actually need the first two terms. I need the quadratic term and I need the linear term. That 15, I actually end up moving that over anyway later on. So I'm going to begin once again by putting the first two terms in parentheses. No extra work is needed here. I'm going to go ahead and write x squared plus 2x, but I'm going to leave some room on the inside and the outside, and I'm going to have my 15 over here. Once again, I'm going to go ahead and take this 2, I'm going to bring it over here to the side, and I'm going to do my magic by completing the square. I take the 2 and I divide by 2 and I square it. 2 divided by 2 is 1. 1 squared is going to give me 1. That's one of those oddballs that are out there where we end up having 1 as our number here. Don't freak out over that. It's going to work out just fine. I'm going to add 1 on the inside. I'm going to subtract 1 on the outside. Once again, when I go ahead and factor this, this is also going to factor kind of unique in the fact that this is going to be x, and the number is going to be 1 and 1. So this is going to be plus 1 and plus 1. When I write this out as a square, I can write x plus 1 quantity squared. Here's my minus 1 on the outside. I still now need to move this 1 over to the other side, just like I had done in previous times. I'm going to go ahead and add 1 to both sides, and I'm left over with the quantity x plus 1 squared is all equal to 16. I can go ahead and solve this now by taking the square root of both the left and the right hand side. I end up with x plus 1 is all equal to plus or minus 4. I'm going to subtract 1 on both sides, and this is going to end my equation here, negative 1 plus or minus 4. I do have two answers here, and because I can put the negative 1 and the 4 together, I can write them as separate integers. So negative 1 plus 4 gets me a positive 3. I also have negative 1 minus 4, which gives me a negative 5. Thus my two answers. Let's go ahead and move over to the next example. The next example does have an issue here. The 10x is actually on the wrong side of the equation. The 10x must be on the same side as the x squared. Although I really don't care about the negative 25, I don't need to move it over. Some students like to move everything over so that it's equal to 0. Other students will leave the 25 there. I'm just going to leave the negative 25 there. I have to move the 10x to the other side. So I'm actually going to begin this by subtracting 10x on both sides so that I have two terms, that both that quadratic term and that linear term. So I need to start off with that. I'm going to go ahead and leave myself some room here because I also know what's going to be happening here. So I'm going to go ahead and put these in parentheses now, and I can go ahead and rewrite this. So I'm going to go ahead and rewrite this x squared minus 10x. I'm going to go ahead and leave myself some room on both the inside and the outside, and I'm going to move this 25 all the way over like this. Now, once again, we're going to complete the square. This is the magic of completing the square. I'm going to take the negative 10, I divide it by 2, and I'm going to square it. Negative 10 divided by 2 is negative 5. Squared is going to be a positive 25. Once again, I'm going to go ahead and put that in a box. Main reason why I put it in a box is so that it doesn't get mucked up in all the rest of this work that I'm doing here. So I'm going to go ahead and add the 25 on the inside. I'm going to subtract the 25 on this side here. When I go off and I factor this, if I go to factor this here, I still have the minus 25 over here. This is equal to negative 25. I'm going to have an x and an x. I need two numbers that multiply to 25 that add to 10. Obviously, it's going to be a 5 and a 5. They both need to be negative because my middle term is negative. And then I can write this as the quantity x minus 5 squared minus 25 is all equal to negative 25. Now, we're going to have another unique scenario here, and we're going to notice this in a moment when I go and I add the 25 to both sides. When I go to add 25 to both sides, you will notice what happens here is I end up with 0. This is okay. 0 is a good number. We love 0. We can multiply by it. I can add it to things. I'm quite good at adding it to things. And so I love the number 0. Students all the time want to feel like they've made a mistake. You haven't made a mistake. It's okay that there is a 0 there. Watch what's going to happen here. I'm going to take the square root of both sides, and I'm going to end up with x minus 5 equals 0 is neither positive nor negative, and thus I don't need to put the plus or minus. You could put a plus or minus there. It'd be kind of silly because when I move this over, you would end up with 5 plus or minus 0. At the end of the day, what you're going to end up with is what we call a single root. It is a double root, though. And so, sorry, we're gonna end up with what we call a double root. There is just one answer, but it is actually represented twice. And so it counts. This is what we have called a double root. Okay, so we only have one answer, 5, but it's actually 5 and 5 is the way that it works. Let's go ahead and move this down once again to this lower part. I have two more for you to go ahead and try. Go ahead and give these a go. This now would be a good time for you to pause the video, and then I will come back here in a moment. Okay, I'm assuming that you paused the video. I'm going to come back and do these quite quickly. Hopefully you have done well on this. And I'm not going to speak. I'm just going to do these quickly to see how you've done. Okay, hopefully you've come back. Take a look at this. Hopefully you did well on these last two. I want to say as thank you for watching.